We talked about alliteration in writing and exponents in algebra. So if I repeat myself a lot tonight, you know why. Welcome to the Introduction to Exponents. You had good grades in math and you want to buy a watch as a present for yourself. Okay, so you deserve a reward, of course. So you want to buy this watch and it costs $360. Now, but you only have $3. You have $3 and you thought of joining a unique lottery. And guess what? You won. But is $3 enough? But check out how this lottery gives prizes. You won a lottery that triples your first bet each day for 5 days. Triples means times 3. So remember, in day 1, you have how much? You have $3. So it triples every day. So from your previous $3, multiply it by 3, that becomes a 9. Okay? Multiply the next day by 3, that's how much? $27. Add up this money now, how much do you have? Okay? How much will day 4 and day 5 winning be? Okay, I'll give you time to think. Ready? All right, here we go. So in day 4, you have $81 because you multiply this by 3. And in day 5, multiply that again by 3, you have $243. Remember how much the watch is? $360. But don't base it here. Add all of these days. Add them up. Okay, let's add them up. And the result is, so can you afford the 360 watch? Add it up, and your answer is, ta-da! 363. All right, so we could say what? Yes, you can buy the 360 watch because you have enough money. All right, you have enough money. So what have we been doing here? We're multiplying 3 times 3, then we multiply it again by 3 again, and by 3, right? This was the thought process that we had. So that's what we've been doing. And this is a repeated multiplication or repeated factors. It's the same thing, all right? And therefore, mathematicians are sometimes lazy. They devise a shortcut method for such situations. What if you have to do this 1,000 times? Will you keep on writing times 3 times 3 times 3? Nuh-uh. They made a shortcut. And the shortcut is called exponents. It looks like this. 3 to the 5th power. Okay? So that means 3 times 3 times 3 times 3 times 3 is made into this way. Okay, how do they do that? And what does it mean? This is a shorter way rather than doing that one. So this is called the base. The base is the number, the big number that you multiply by itself, to itself. Okay? So this is 5, is the exponent or the power, the number of times you multiply the base to itself. Also, this is read as 3 to the 5th power, 5th with a TH, and 3 raised to the power of 5. Power of 5. Any of those statements will be correct. The values of numbers in exponent form. So this is called the product expression. Okay, a repeated factors. So to solve this, okay, what did we do? We did 3 times 3, 9. And then times 3 again, 27. Times 3 again, 81. Times 3 again, 243. Okay, that's fine. This is the value of 3 to the 5th power. You could do that with your calculator or you could do it mentally. But there is a big mistake. What is the big mistake? Students would often do this. 3 to the 5th power, they just multiply the 3 and the 5 to make it 15. Or sometimes they do 3 plus 3 plus 3 plus 3 plus 3, which is 15. Is 15 the same with our value of 243? No. So therefore, do not do this. This is not allowed. So never do that. You cannot multiply the base and the exponent. So using your calculator to solve for the value, we already know that. The long way is, okay, your trusted calculator. The long way is just multiply 3 and then the times button times 3 times button 3 times button 3. And then times button, times 3 again, 10 times button, then equal, you get 243. Okay? Now, check this out. You can also use a special button over here it says x to the y. It looks like this. 3x to the y power. X to the y power. That means 3 is your base. Click this button, x to the y, and then click 5, and then you will get equal sign, then you'll get the same answer, 243. Okay, so remember that. You can either use repeated multiplication or the shortcut key y to the x power. Y to the x power. This one. It's over here. Where's that? Here. Okay? Now let's practice with these. Be ready with your trusted calculator. Remember the y to the x button. This will help you. So the first one, you could simply write the product expression. 7 times 1, 2, 3, 4, 5, 6, 7. And then you could use your calculator and you get a value of correct. All right. How about this? Simplify this as, how many 4s do I have? 1, 2, 3, 4, 5, 6, 7, 8. I'm lazy to do that. So therefore, I write 4 to the 8. Awesome. Next. So I get the value. I get my calculator. And my answer is yes. All right. Oh, this one. What could be numbers when multiplied will give me 1,000? And take note, the base should be the same. Yes, correct. So that's 10 to the third. So 10 times 10 times 10. Next, 9 to the fifth. Write it down 5 times. But it's not 9 times 5. And the answer is 59,049. Now, this is another set of problem. Try it on your own. Pause. When you're ready, I'll show you the answers. Now, here are the answers. Two answers here. Now, this is a real-life application. Check out the problem. The exponential spread of a virus. What happens here? Okay, virus, very relevant, right? So this is an infected patient. He got the virus and he meets 2 people on day 1. And then these 2 people would meet 2 other people. And then these 2 people would meet 2 other people again. Okay? How many new contaminations are there each day? Let's start with day 1 is when these 2 met patient number 1. So there are 2. Day 2, there are how many new ones? 1, 2, 3, 4. There you go. For day 3, there are 8. For day 4, there are 16. And day 5, there are 32. Also, you could write this as an exponent. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Do you agree? Yes. I have a challenge question for you. How many new infections will there be on the 10th day? Can you predict? I don't have enough space for that. I don't need to make additional dots. That's too much work for me. So can you predict? Okay, I'll give you a clue. Look at the days and look at the exponents. See a pattern? Okay, you got it? Good. Now you're getting it. So day 10 would be 2 to what power? 2 to what power now? Yes, 2 to the 10th. And you could use your calculator. That's 1,024 new infections. That's a lot. Now this is another problem. Okay, another challenge. This person did not meet patient number 1. So therefore, it has lessened the contamination. But for here, day 1, the result is 1 person. Day 2 will be this 2. Day 3 will be this 4. Day 4 will be this 8. And day 5 will be this 16. Write that again as exponents. Correct. 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. Question. How many new infections will there be on the 10th day? Think of, is this the same as the other one? No. Again, look at your day and look at your exponents. Can you see a pattern? Okay, are you ready? All right, here we go. Day 4 is an exponent of 3. Day 5 is an exponent of 4. Therefore, I took away 1. Therefore, 10 minus 1 is 2 to the 9. Correct? Because we took away the 1. Get your calculator and the result is 512. See, it's less infection now because of this person who did social distancing or not going out at all. He quarantined himself. So that's the importance of staying away from infected people. This is a concrete example of exponents in real-life situations. In the next videos, we will be talking more about rules of exponents. What if we add them, multiply them, divide them? Okay? There are shortcuts for it, but we will discover it in the next videos to come. Okay, bye! Don't forget to subscribe and get notifications. And watch out for the next videos.